All right, welcome back, guys. This chapter could get long, and there's a lot of different facets to this. So we're gonna see how long I'm gonna make this video because if I get an idea in my head, I'll go off and start explaining something else. So what I would really like to cover in this is the structure of if-else statements and decision making. The logical operators. Last time we went through arithmetic operators. The arithmetic operators were your addition, subtraction, that kind of stuff, greater than, less than. But the logical operators, you'll need to know that for decision making and if-else statements. And I'd like to do some Boolean algebra with truth tables. So let's get started here. I'm going to open up my my sketch screen, and we'll just start talking about if statements. So let's say I've got a variable age. I'm going to say if age is greater than or equal to 21. Okay, and instead of doing system.out.println and writing all that out, I'm just going to do s.o.p. And if your age is greater than or equal to 21, you can go to bars. Okay. All right, and so what I always tell students, you want to open up your brace and you want to close your brace once the if statement's finished, okay? And what that does is that, you know, this lines up, okay? This is where the if statement starts and this is where it ends, okay? Let's try to... All right, so that makes sense, all right? But maybe you want to do something with an else in there. Like, let's say you're not 21. You'll just do something like this, else s.o.p, you know, I don't know, go home. You know, you're not allowed in, okay? And so this is how your computer makes decisions based on its variables. If this is true up here, you can go to the bars, else you got to go home, all right? But there's a whole lot more to this. Let's say, let me erase this. You can have just a standalone if statement by itself, that's fine. But most of the time you want to start having else statements in there, and you want to start having actually what's called nested if statements. So let's say this, if your age is greater than or equal to 21, also, you know, you can vote. Okay? And at the same time, you can drive. Now, I'm just assuming age-wise. Now, I'm not saying maybe you can't drive because you don't have a license, okay? But I'm just assuming age. But if all three of these things if your age is greater than 21, all three of these things are true, okay? So we print them all out. But we could do something like this. Else, if age is greater than or equal to 18, you know, there's some stuff that you can do as well. Okay, you can s.o.p, you know, you can vote. Okay, and s.o.p, you can drive. Okay. Then I'm going to go on. I'm going to say else if age is greater than or equal to 16. Make that look a little bit better. s.o.p, you can drive. Okay. All right. So then the last thing what you need to do is you need to have a final else, because maybe they're not even greater, maybe the person's not even greater than 16. So you'd have something like s.o.p, I don't know, you're an infant. Okay. All right, so notice I know where my if statement starts right here and it ends right here, and these line up nicely, okay? This makes it easy on the eye. When we're typing this out in a program, we tab that over right there, okay? So that's the basic structure of your if, else if, and else statement. And this is how the program decides, you know, what's going to display to the screen and what's going to run. Okay. All right. Let me delete this and let me go into my logical operators. Okay. Logical operators. Okay, my logical operators are my AND operator. This stands for and or both. I'll switch these back and forth, these two words, and both, okay? That will make more sense here in a second. We've got our or. Now these are called pipes. So you press shift and the button above the enter button to enter these pipes. But this means or. Okay? One or the other. Okay? That will become important. And then we've got our exclamation point, and that means not. Okay? So these are our logical operators, and you'll want to memorize those, all right? So we've got ampersands, which are what, shift 7? 2 ampersands, 2 pipes, shift the shift and the button above the enter button, and your exclamation point, which shift 1. Okay, so I'm going to delete these, and I'm going to go to truth. I'm going to show you guys truth tables. All right. So remember we talked about our primitive data type Boolean. Okay, and Booleans can be true or false, okay? They hold true or false, all right? So if I have a few variables, let's say I have A or a couple variables, and I have B, okay? And A, whoops, okay, A and B, and I had the statement A and, let me write these out better, sorry guys, writing on the screen isn't the easiest thing to do. A and B. Okay, and we wanted to evaluate the truth table. Now this is Boolean algebra for you people out there that are into math. Okay, let me draw out my table here. All right, so A can be true and B can be true. A can be true, B can be false. A can be false and B can be true, and A can be false and B can be false. So true and true. What does this evaluate to? Well, is A true and B true? Yes. So if they're both true, this statement evaluates to true. Okay. A is true and B is false. Okay. Are both of these true? Is A true and B true? No, B is false in this. So true and false evaluates to false. Okay. Then we've got false and true, and that evaluates to, okay, are both of these true? No. So the whole thing is false. And then we've got false and false evaluates to false. So true and true is true. True and false is false. False and true is false. False and false is false. Okay? You can use this for so many different things, and once you get good at it, it just makes perfect sense. So let's go through the ors now, okay? Let me see if I can get in here. Get these all. Okay. All right, so now we've got our logical OR operator. True or true. Is one or the other true? Well, these are both true, so this has to be true. Okay? True or false. Is one or the other true? Yes, A is true, so this evaluates to true. False or true. Is one or the other true? Yes, B is true, so the whole thing is true. False or false. Is one or the other true? Nope, so the whole thing is false. So true or true is true. True or false is true. False or true is true. And false or false is false. Okay? Memorize these truth tables. They're important, okay? And they help a lot with stuff. So this would be something like, let me delete this. Let's say we wanted to find the largest of three numbers, okay? And we didn't know what values were stored in those three numbers, or those three numbers could change. So I have three variables, okay? I have num1, num1, and we'll just say they're ints, num2 and num3, okay? And we wanted to know which one was the largest one, okay? So we could do something like this. We could say if num1 is greater than, let's say just, are we going to worry about equal numbers? Let's assume that none of the numbers are equal, okay? Because this would screw up this example. And I just want to demonstrate this for you guys, and I don't want to think through if they were equal. But if we know that the numbers aren't the same, we want to figure out which one is the largest. So if num1 is greater than num2, okay, and num1 is greater than num3, okay, then we could do a system.out.print and say num1 is the largest. Okay? And that makes sense. If 1 is greater than 2 and 1 is greater than 3, 1 is the largest. Okay? Then we could go down here and we could do some other stuff. We could say else if num2 is greater than num1 and num2 is greater than num3, then, and I forgot to put there you go. And, okay, so s.o.p, num2 is largest. Okay. And so if 1 isn't the largest and 2 isn't the largest, then what does 3 have to be? 3 has to be the largest. So you just do s.o.p and go num3 is largest. All right. Pretty easy so far. Let's think here. What were some other things I wanted to go through with you guys? Maybe this video isn't going to take too long. The only other thing that I can think of that might screw you up is, now let me delete this. Okay. We need to start thinking about the difference between equals, and dot equals. Okay. So, equals means a sign. Okay, it's assigning a value. So A equals 5. Now A after the statement, A is equal to 5. Okay. Equals is checking for equality. Okay. And this is with primitive data types. Okay? So if, let's say here, let me write it down. Let's say we've got two integers. A equals 5 and B equals 5. So you would say if A equals B, you know, S dot O dot P, A is equivalent to B. Okay? You cannot do this. This is trying to assign A to the value of B inside a conditional if statement. This will give you error. Okay? This is an error right here. Don't get that screwed up. You have to check for equality using equals equals. Okay? And you do it with primitive data types. The primitive data types, again, are int, double, char, and boolean. Those are the main ones that I use, okay? I'm trying to think of there are other ones. If you got bigger ints, those end up being longs. But usually we just stick with ints, okay? So equals equals is checking for equality inside some sort of conditional if else statement, all right? Dot equals is different, and I don't know if I want to go into the whole lesson on strings because that's, that's a lot. Do I want to do that? Because then I have to talk about string literals and string objects. I kind of want to do that at some point, but maybe not right now. All right, so let me do this. Dot equals, okay, this is checking for equality or quality between strings. So we could have name 1 equals, I don't know, James. And we could have name 2 equals Jim. Okay? And these would both be strings right here, by the way. String, string. Okay? So if we had if name 1 equals name 2, you have an error there. Okay? Strings are objects. Strings are objects. And if you do this right here, you're actually going to check to compare if name 1's memory address is the same thing as name 2's memory address. And they're not going to be, objects are stored in memory, and they're not going to have the same memory address, all right? So this gets all screwed up and jacked up, all right? So what you need to do here is for strings, you need to say dot equals name 2, okay? And so what this does, almost never do you want to look at the memory addresses and see if they're the exact same object. You would never want to do that. What you want to do is look at what's stored in the object. James is what's stored in the object name 1, and Jim is what's stored in the object of name 2. Okay? And so using dot equals will compare if the strings that are stored in them are equal. Okay? I think I'm going to probably have to do something with string literals and string objects at some point as a video. I'm going to look at the book and see where they start teaching about strings. But just know that dot equals is what you need to use when you're using strings. Okay. Let's see here. there anything else I want to cover in this real quick to help you guys out? Okay, let me delete this. Let me look here. If there's anything else. These are examples of what I give my high school students, because I actually kind of teach this class more testing. I know you guys don't have to take tests in here, but you've got something like, your int age is 28, A is 28, B is 47. So is A less than 30? Okay. It's true, right? A is less than 30. So if this is true, okay, and then you got C is greater than, C is 84. Is 84 greater than 85? This is false, okay? So true and false, that whole thing turns into false. So we don't run this. Else if, now I try to mess with my students' heads and write the code funky to see if they can read through this kind of stuff. But else if B is 47, is 47 greater than 50? Nope, but it's an OR statement, so is A greater than 28? This is true, okay? This is false. And we remember our truth tables, false or true is one or the other true. Yep, this one's true, so what does it print to the screen? It prints goodbye. Okay, so that's kind of example of some stuff I do with the students. I gotta close this. I'm gonna look at a couple more. No, I didn't want to look at that. Let me see here. Worksheet 2. I think this was like the last thing I wanted to. Quiz 5. That's one. Second, let me look for this. All right. Sorry about this. I thought I had this open. There's one other concept I want to kind of show you guys, which may kind of mess you up if we don't get it taken care of right away. So intro to programming, chapter 5 quiz. Okay, where'd that go? This one right here. All right, so let's look at this. This would be an example of a piece of code that would have errors unless you fix them. Now, an easy way to fix it, well, let's talk about the errors. Okay, so if num2 equals 0, we do system.out.println, and it looks like it's fine, right? It looks like it's going to run this, then this, then this. That's going to be a problem, though, because in order to run 3 things, we have to do this right here and that right there. Okay, we have to have opening and closing braces if we want. Excuse me, I'm going to sneeze here. Excuse me. All right, so without those closing braces, what it does is it says if, without these on here, we've got major problems that the compiler doesn't know how to deal with this, okay? So if we have this if statement right here, it wants to do this first one, and then this is, it's like sitting in limbo right here because it doesn't know, like, okay, I need to move on to this else, or what's going on. So in order to fix this stuff, you need to put the braces around it so that it does all of them, okay? And that's about it. I thought I was actually going to have more information for you guys on this, but I think that's a pretty good wrap. Shoot me an email if you've got questions, and I'll answer those for you, okay? Have a good night. Thanks. Bye.